What is the Border Gateway Protocol? Remember that the internet actually consists not of a network of computers, but of a network of computer networks, or autonomous systems. The Border Gateway Protocol is the fundamental protocol that these systems use to figure out how to take a packet and transmit it farther on in the internet. So the Border Gateway Protocol is fundamental to the idea of how routing works. And let me demonstrate how it works using this simple example. So I have 4 computer networks or autonomous systems here. Remember that all the internal routing inside each of these networks has to be done by the autonomous system itself. So to use UB as an example, once a packet that's destined for a computer arrives at the University of Buffalo, the core internet has done its work. It's finished. It says, okay, I've given this to the router that is assigned to serve at the University of Buffalo, and it's now your job, it's sort of the job of the people who administer our autonomous system to make sure that that packet gets to its destination. So let's imagine that these 4 autonomous systems have peering relationships with each other like this. So A is peered with C and B. That means that the autonomous system A has connections to this autonomous system C and to its autonomous system B. And so A can directly send packets that are destined for this system to C and to B. Same thing with these other autonomous systems. And so to some degree, this starts to look a little bit like a typical routing diagram where I've replaced nodes with autonomous systems to better reflect how the internet routing protocols actually work. So the Border Gateway Protocol, or BGP, is what the routers in these networks, it's how they exchange information about what they should do with a packet that arrives at their network. Because, for example, B, in order to reach C, if someone inside B's network wants to transmit a packet to someone inside C's network, B has to either send the packet to this autonomous system A first, or it has to transmit the packet to autonomous system D. And the Border Gateway Protocol has 2 functions. First of all, it allows the autonomous systems on the internet to figure out who they can communicate with. So it has to do with reachability. What hosts on the internet can I send packets to? And it also helps that this particular router, let's say we're starting in autonomous system B, it helps it make this fundamental choice that router has to make over and over and over again, which is, should I send the packet to D or should I send the packet to A? So let's walk through an example. So the way the Border Gateway Protocol works is that the routers inside these autonomous systems periodically exchange information with each other that records or represents the different autonomous systems that they have direct connections to. So for example, the Border Gateway Protocol might operate as follows. The router inside A would send a message both to the router in B and to the router in C. And what that message would say is it would say, I know how to talk to B, and I have a 1-hop link to B, so I'm directly connected to B, and I also know how to talk to C. And that's, at this point, when the protocol is bootstrapping itself, that's what it sends. Now, once B receives this message, the first thing it says is, well, you know what? I'm directly connected to A. And so that's not interesting to me. I know how to get packets to myself. I don't need to send a packet that's destined for my own network to A. So, but it does say, oh, this is interesting. I'm not directly connected to C, but now I know how to get a packet to C. So if I want to send a packet to C, it maintains a table that says, I know how to get packets to B. That's myself. I have a 0-hop link, so internally I'm going to route things. I also know how to get the packets to A. I knew that before because I'm directly connected to A. And I knew how to get packets to D. Again, I'm directly connected to D. But because I received this message from A, I found out a new piece of information, which is that now I know that there's this network C, and I know how to get a packet to C. In order to get a packet to C, what I'm going to do is I'm going to send it to A. And because A told me it has a direct connection to C, the length of the trip from my network to C, I'm going to record as 2 because it requires sending it to A and then to C. I have it again. So this is what the routing table that's used at B is going to look like after it receives this message using the Border Gateway Protocol from A. So it knows Anything destined for my own network I handle internally. Anything destined for networks A or D, I can send directly to those networks. And if I need to send something to network C, I can transmit it through network A. Now, the way the Border Gateway Protocol works is that these routers are periodically sending this information. And so what B would do is, once it receives this information, it would send a message to D with all of this information. D is going to receive this information, and once D receives the information, what D's routing table is going to look like is it's going to say, I know how to route things to myself, I knew how to route things to B and to C before, but now what I'm going to discover is somebody knows how to get a packet to A, and that network is B, right? So if I want to send a packet to A, I transmit it to B, and that's a 2-hop link because B is going to then transmit it on to A. Once all these routers have exchanged information, one interesting thing to notice is that B obviously has 2 routes to get packets to C. One is to send it through A. The second one is to send it through D. And choosing between those, B could choose to send packets in both directions depending on load. B might have some other way of breaking ties between these networks. It might say, well, I prefer to send things to network D because my connection's a bit faster or something like that, and so I'm going to do it this way. So this is how the Border Gateway Protocol, a very simple example of how the Border Gateway Protocol uses these advertisements about reachability to allow each host on the internet to build up a routing table that essentially allows it to route to any autonomous system that's connected to the internet. So in order to route data, the routers at UB actually have to know which direction to send packets that are potentially destined for every autonomous system that makes up the internet.